to 4. So will be equal to, so V is our constant. So leave V outside. Integrate 0 to 4, 36 over 233. Multiply Z, dz. And then T, I'm going to leave it outside. Okay, they are constant. So from here, this will be equal to VT. Right, so 336 Z squared divided by 233 times 2, 466. And then is 0 to 4. So VT bracket, so 4 squared times 36 divided by 466 is equal to 288 over 23. Okay. VT. Okay, so we have our FBD. So to find the shear center, we don't need to bother about FAB. Okay, so to find out, I'll write down here note. To find shear center, right? We don't need or FAB. Sorry, is it FAB and FEG? Right, FAB and FEG is not required. Okay, FEG. Any idea why it's not required? Anyone? Right? Anyone why FAB and FEG is not required to find the shear center? Anyone?
It doesn't create moment about
Yeah.
C.
Exactly. It does not create a moment at all. So that's why you don't really need it at all. Okay. If it creates a moment, then you need it. So it does not create a moment. So that's why for this case you can ignore it. Okay. So from here,
I was confused as how we got 233 over 12 for the I for this section.
where?
We got
Which
233 over 12 for
Yep.
for I. Oh, okay.
Yep.
Sorry. Yeah, I see it. Thank you.
All right. So because I multiply by t, that's 1 over 8, right? As I said earlier, I leave the t down here initially, not as a magnitude, but a variable t. So in this case, I know that I can remove it because it's very small. That's why I leave it as t. Right. So now we're going to take. Okay. So now I'm going to call this again point C. So this is our centroid. Right. So I'm going to take moment about point C, and we know that we have FBD, and we know that this is FEF, right? So that and the offset V over here, right? The shear center, they are the one going to cause the moment. So like what one of you have said, FAB and FEG is not going to cause any moment because we're going to take moment about C. So moment is equal to force multiplied by perpendicular distance, right? So from here, summation of moment in the Z direction at point C is equal to 0. So you have FBD. So FBD and FEF is going to generate anti-clockwise. So positive FBD. So twice of FBD multiplied by a distance of 3, right? Force times a perpendicular distance. Then you have plus by V, and then you're going to multiply E, right? So all are going in the same direction relative to point C. So VE is equal to minus 6 FBD, right? So if we find our BD, which is equal to 288 over, I think I missed up something. So 36 times 4 times 4 divided by 4, 66. Okay, sorry people, this is 288 over 233. My apologies, okay? So this will be equal to VE minus 6 multiplied by 288 over 23 or 233. And then did I include a VT? Yep, VT. So you can cancel the V's. So the E is equal to, so 6 times by 288 divided by 233 is equal to is equal to 288 times 6 divided by 233. So this will be equal to 1728 divided by 233 multiplied by the thickness over here. Thickness will be equal to 1 over 8. So times by 1 over 8. So this is 0.927 inches. No doubt, yeah, there's a negative, means it's on the left hand side. Okay, so E is equal to mod towards the left minus 0.972 inches. Okay, so the next one, so this is pretty straightforward now. So the next one is we are going to find, right? We're going to find the stresses now, the stress distribution. Okay, so we're going to find, you're going to find the shear stress distribution okay. So the formula we're going to apply, right? The formula we're going to apply is shear stress is equal to VQ over IT. Standard formula. Okay. So I'm going to copy this image again. Oi, undo. So from here, if we look at specific point now, okay, so we're going to find, okay, we're going to find, and we have to be careful down here, okay, so we're going to find, right, we're going to find the shear stress at point A, shear stress at point B, point D, point E, point F, and shear stress at point G. And we're also going to find where is our shear stress max. Okay. So if you look at point A, so let's look at all the outer points. Okay, so let's look at all these points over here. So look at point A, point D, point F, and point G. What we can say down there is that the shear stress wrong color, sorry. The shear stress at point A, shear stress at point D, shear stress at point F, and shear stress at point G, they're all equal to what? 0. Right? Any idea why? Why they are all equal to 0? Anyone? No takers? This is because the first moment of area are equal to what? 0. Yes? the first moment of area is equal to 0. Okay. Now, let's look at point B now. Okay, that's where it gets tricky. Point B, right? There are three major sections. At point B, if you look at point B, there are how many points? There are 3 points. What do I mean by 3 points? You have 1 point over here, right? You have 1 point over here, and you have 1 point over here. Okay. So as you know that if our shear force is V, this will always be our flange. Okay. And this will always be our what? Our web. Okay. So if we look at point B, okay, so the first thing, so point B has 3 points, not 1, right? So we are going to look at point B. Okay, we're going to look at point B in the flange. Okay. So I'm going to call this, okay, I'm going to call this tau B flange. Okay, so where tau B flange is, this is where tau B flange. Okay, so the B is more in the flange side, okay, not on the web, not B at top of the web or the bottom of the web. Okay, so we're going to find that. So the first moment of area, Q, is equal, so the area is equal to width is 4, thickness is 1/8, and depth is and the y bar is 3, right? So this will be equal to 4/8, or 4 times by 1/8 times 3, so it's equal to 3/2. Okay, 3/2 inch cube. So the shear stress at point B at the flange, so the V, right, we are going to apply the formula VQ over I. So the V is equal to 2.75 times 10 power 3. The I we found is 233/12. Right? The Q is 3/2. And the I is, or the thickness is 1/8. So this will be equal to 2.75. Power 3 times 3/2 divided by 233/12 divided by 1/8. So it's equal to 1700 psi. Okay. So the next one, we're going to find the shear at B for the web. So where do I mean by this? Okay, for the web. So it should not be a close F, right? So this is this point over here. Point B just at the web section. Okay. So when that's the case, your Q now, right? Now only change like what? So the rules still apply. V and I are constant. T is depending on what section you look at. Q is your what? First moment of area. Okay, nothing changed. So the width is 1/8. The thickness, the area. Okay, the area. So the width is 1/8. Okay, the depth is 2. And then the distance from here to here, this will be equal to 1 plus 3, right? So this is 1 plus 3. So you have to consider, so the first one you have to consider is this area over here. And then the one we did before is this area over here. Okay. I mean, I'm going to draw slightly over. Okay, or not, some of you get confused. Okay. So when that's the case, you have 1 over 8